Okay, moving on, let's say that we've been allocated class C, 200.15.10.0/24, again, the same as the last example. And here we're going to move the line all the way to the right. We're going to go with a /31. Obviously, we can't do a /32 if we want to have more than one available host now. You can use a /32 subnet mask, but there's only one host there. That's mostly used for loopback addresses. Don't worry about it yet. We're going to talk about that later on. So if you do need to have multiple hosts, then the furthest right you can go is a /31. If we wrote that subnet mask in dotted decimal notation, it would be 255.255.255.254. We get the 254 because it's 128 plus 64, 32, 16, 8, 4 plus 2 comes up to 254. So that leaves 1 bit for the host address, which has obviously got a possible value of a 1 or a 0. So a class C, a /31, it borrows 7 bits for the network address from the host address. That gives us 128 subnets, which is to the power of 7. Again, let's count it up. 2, 4, 8, 16, 32, 64, 128. And that's going to accommodate 2 hosts each. So that's what we get with a /31. The valid host addresses would be 200.15.10.0 to .1, 200.15.10.2 to .3, then 200.15.10.4 to .5, etc., all the way up to 200.15.10.254 and 255. You can check this by, we're using 200.15.10, so the first 3 octets are never going to change. The last octet, you just start with all zeros, and then it would be 0000001, and then a 0 or a 1, and then 0000010, and then a 0 or a 1, and so on. Okay, but wait. If we're using a /31, there's only 2 possible values to assign to hosts. What about the network and broadcast address? Yeah, a /31 subnet breaks the standard rules of IP addressing, where we have to have the network address and the broadcast address at the top and the bottom of the range. /31 subnets are, however, supported on Cisco routers for point-to-point links. If you think about it, a point-to-point link, there's just one side and the other side. Well, any traffic that comes from here needs to go to the other side and vice versa. There's nowhere else for it to go, so there isn't really any point in having a network and a broadcast address. So that's why Cisco allowed that exception. You can have a /31 on a point-to-point link. Okay, next up, moving on, we're going to move the line back a space. We're going to create a /30 now. The subnet mask in dotted decimal, 255.255.255.252. That and /30, they both mean the same thing. That is going to leave 2 bits for the host address, because we got 2 bits for the host address. 2 to the power of 2 is 4, minus 2 for the network and the broadcast address. That gives us 2 possible hosts. It borrows 6 bits for the network address. If we count this up, 2, 4, 8, 16, 32, 64 is our 64 bits, which can accommodate 2 hosts each. The valid addresses are, on the first subnet, the network address is 200.15.10.0 and the broadcast address is 200.15.10.3. The valid addresses are .1 and .2. The next subnet is 200.15.10.5 to .6, and the network is .4, the broadcast is .7. The next subnet, the network would be .8, the valid addresses would be 9 and 10, and the broadcast would be .11, and so on. Okay, as you look at this, the way that you can calculate what the different valid subnets are going to be, notice where the line is, it's after the number 4. So the network address is going to go up in values of 4. The first network address is .0, the next network address is .4, the next network address is .8, .12, .16, and so on. And because we know the network addresses, we can work out what the broadcast address and the range of valid IP addresses are going to be. So here, it's going up in values of 4. The first subnet is going to be a 0. So 0 is the network address, And because the next range starts at .4, the broadcast address must be .3. So if 0 is the network address and .3 is the broadcast address, the valid host addresses must be .1 and .2. The next subnet, it starts with 4. The next subnet after that is at .8, so the broadcast address must be .7. So network address of .4, broadcast address of .7, that leaves the addresses in between of .5 and .6 are available to be assigned to our hosts. Okay, let's look at a comparison between the /31 and the /30 now. Hopefully you noticed that they both supported 2 hosts per subnet. But a /31 supported 128 subnetworks, a /30 only supported 64. So you're maybe thinking, oh, well, we're always going to use /31 then. And a /31 is useful if you need to maximize the use of your address space. But a /30 is more commonly used, it's more standardized. For the CCNA exam, if you get a question where you've got the choice where you could use either a /31 or a /30, always use a /30. So if the question requires you to come up with a subnet that supports 2 hosts, use a /30 unless the question explicitly tells you to use a /31. Okay, so we covered a /30 and a /31. Next up is a /29. So we're going to move the line back a space again. A /29 in dotted decimal is 255.255.255.248. Again, we get the 248 because it's 128 plus 64 plus 32 plus 16 plus 8 up to where the line is. That leaves 3 bits for the host address. 2 to the power of 3 is 248. 8 minus 2 because of the network address and the broadcast address gives us 6 available host addresses. And class C, the default subnet mask is 24. Here we're using a /29, so we're borrowing 5 bits for the network address. 2 to the power of 5 is 2, 4, 8, 16, 32. So we've got 32 available subnets here. The valid host addresses, notice that the line is after the 8. So the network addresses are going to go up in values of 8. The first one will be 0, then 8, then 16, and so on. So the first subnet, the network address is 0. The next subnet, the network address is 8. So the broadcast address for that first subnet must be 1 less. It's going to be 200.15.10.7 for our example. So if the network address is .0 and the broadcast address is .7, that leaves .1 to 6 available to be assigned for our hosts. The next subnet is going to be, we said already, starts off with .8. The next one is at .16, so our broadcast address now must be .15, 1 less, which leaves the available host addresses of .9 to .14. And we can go on like this all the way up to 200.15.10.248 is the network address, .255 the broadcast address, with host addresses 249 to 254. And we can carry on moving the line back a place. So we did /31, /30, /29. We could also do a /28, which is 255.255.255.240. That is going to give us 16 networks of 14 hosts each on a class C. Again, the default is a /24. If we're using a /28, we've borrowed 4 bits. 4 bits is 2, 4, 8, 16 available subnets. And after 28, it goes up to 32. So we've got 4 bits available for our host addressing. That is 2, 4, 8, 16 minus 2 for the hosts, which gives us 14 available hosts. We can move the line back again to a /27. That's going to be borrowing 3 bits, so that is 248 available networks, leaving 5 bits available for our hosts, which will be 2, 4, 8, 16, 32, minus 2 gives us 30 available hosts. You can see how I'm getting that now. A /26 is 4 networks and 62 hosts. A /25 is 2 networks and 126 hosts. And /24 is the default 1 network with 254 hosts. Okay, so that's how we carry out subnetting and figure out how many networks and how many hosts we're going to have. Next thing to tell you about is variable length subnet masks. With early routing protocols like RIP version 1, they only supported fixed length subnet masks, which meant you could subnet, but all subnets in a particular network had to be the same size. So all of your different subnets had to accommodate 14 hosts, for example, or 30 hosts, for example. And if you had one subnet that needed up to 30 hosts, you had to have all your subnets at a size of 30 hosts, even if one of them only had 3 hosts in it. Then, with later routing protocols, they came out with support for variable length subnet masks. That means that within the same range, you can have different sizes of subnets in there. So say I've got one part of my network which has got 10 hosts in it. I could give them 14 available hosts, and another part of a network that's got 28 hosts there, I could give them a subnet mask that gives them 30 available hosts. Okay, so variable length subnet masking, it means we can use different length subnet masks within the same network. This is a good thing because it lets us be much more precise with the size of our networks, and we're going to be wasting a lot less addresses. We'll cover how to do VLSM, variable length subnet masking, in the next lecture.